everybody. Good morning. Welcome to day 2. I see most of you are no worse off for last night, so glad to see that. And then welcome everybody joining us on the live stream. Hopefully everyone enjoyed day 1. I know we had lots of great programming and even more in store, I should say, today. So I know yesterday we started off and spent most of the day talking about the security and the networking layers. So probably not going to shock anyone. Today I want to spend a little bit more time on the infrastructure and the application layers. Lots of exciting stuff for us to talk about, so I want to jump right into it. So maybe starting first with the sort of infrastructure layers, right? I think the way we often think about this, and you kind of saw us talk about it a little bit yesterday, is there's really almost 2 different types of audiences when we talk about within an organization. We generally have our core platform or our sort of, I'll call it our cloud teams, our SRE teams, right? We might call them different things in different organizations, but they're the folks that are generally responsible for operating the core infrastructure and providing the set of shared services that our application teams are consuming. Then on the other side, you obviously have our application teams or our development teams that are really focused on what's their application, what are they sort of adding business value in terms of building their own services, and they're a customer of those internal platform teams or internal sort of enablement teams, right? So we often think about these 2 distinct audiences and what each of them are trying to solve and what each of them sort of cares about, right? And so often when we talk about infrastructure, it's really more in the realm, the core infrastructure is owned by those platform teams. It's a bit more of their concern than it is the application team's concern. For the app teams, it's more of a detail, but it's an essential detail. So maybe starting off at that infrastructure level, what we tend to see is almost 3 core phases to every company's journey, right? The first is really about establishing a practice of infrastructure as code. I think for a lot of organizations, that itself is a shift from maybe more traditional approaches, whether it was ticketing or sort of point-and-click UI driven. So it's about how do we just establish that practice? Then there's a question of, okay, how do we standardize it at scale, right? As we go from the first team to maybe 5, 10 different teams doing it, I don't want every team reinventing the wheel of how do we define core databases, how do we define networks, how do we define these core services. We want some level of standardization and consistency at scale. And then the third piece is really how do you then operate and optimize as you're operating at scale, right? Whether that's putting in security, compliance, cost guardrails. It's making sure that, great, now we have 50 app teams doing it. We want to do it in a way that's sort of sane. And so kind of across all 3 of those is really where we've been focused with Terraform for many, many years, right? I think about one whole class of our focus is really thinking about what's the developer workflow, right? So as we think about infrastructure as code, how do we make that really elegant? How do we make that really simple? Whether that's a focus on the command line experience, whether that's a focus on the UI experience with Terraform Cloud, whether that's VCS and CI-driven integrations. What's that end-to-end workflow and how do we make it simple? Then there's a question of extensibility, right? We realize infrastructure doesn't live in a vacuum, right? You have hundreds of different services and tools that you need to integrate with. So how do we make Terraform extensible to support all of that, right? And then lastly is the management and life cycle of our infrastructure doesn't stop with day 1, it only begins with day 1, right? So then how do we think about the management of that infrastructure over time? So when we talk about Terraform, it's been a long journey. I talked to a few folks yesterday and this morning in the hallways that I think are sort of new to the Terraform community. So welcome. We're glad to have you here. But it's certainly been a long road. So it's fun to kind of look back and just see where we are today versus where we started. Right? Hard to believe Terraform 0.1 was almost 8 years ago, right? 2014 is when we first released it. And today, now when we talk about it, it does over 100 million downloads a year. So just a crazy, crazy difference from where we started. Then when we sort of talk about how do we think about that standardization, that reusability, creating those repeatable blueprints, we introduced the Terraform registry in 2017 to solve that problem, right? Today, we do have over 10,000 modules as part of that, some of which have been downloaded tens of millions of times, right? Then when we talk about, great, how do we think about extensibility? That's where the provider program comes in, right? To really allow us to have those extensible integrations and plug into all of the different systems we want to manage with Terraform. And so today there's over 2,400 of those providers in the Terraform ecosystem, right? So you can really see the explosion and growth around it. Then when we talk about sort of operating at scale, right, that's really where we introduce Terraform Enterprise. and today count over 470 enterprise customers on that platform. A key workflow is really the notion of policy as code, right? So we introduced Sentinel and the whole framework and idea of policy as code, and I think we've seen that grow in popularity since then. And so since we introduced it, certainly at least on our own platform, we've done 3.5 million policy checks as part of Terraform Cloud. So really seeing a growth in the idea that we want to move away from sort of a ticket-driven or human manual-driven approach to policy enforcement towards an automated sort of policy as code workflow, right? We wanted to bring that Terraform enterprise experience to our broader user base. So with that, we introduced Terraform Cloud in 2019. And since then, we've seen a massive growth to over 250,000 users on that platform as well, right? Then last year, we introduced run tasks. So this is the idea that we want to extend Terraform Cloud, Terraform Enterprise to be able to plug into our different systems, whether that's Sneak for security scanning or CI tools or cost optimization. And so since then, there's 15 official partners and over 300,000 moments in time where we've actually prevented a Terraform apply based on a policy check that failed, right? And this might have been driven by an external partner, whether for cost reasons, security reasons, compliance, et cetera. And then lastly, earlier this summer, we introduced drift detection, this idea that we want to be able to continuously check for drift from Terraform and alert users proactively. That only was beta, late summer, and since then we've had, over 2,000 organizations enable that as well. So super excited to just see the progress around Terraform. So now I want to flash forward and spend a little bit of time and have one of our customers, City National Bank, share their story about how they've gone through exactly those journeys of establishing a practice, standardizing, and operating at scale. So I'm going to hand it over for a minute to John Tan, SVP of Enterprise Infrastructure, to share with us their journey.
Thank you, Armon. Hello, my name is John Tan. I am an SVP here at City National Bank, and my role is the Senior Manager of Enterprise Infrastructure. Under my purview is cloud architecture, cloud engineering, cloud SRE and operations, and network security. I'm excited to be here today and share with you the details of our cloud journey, as well as our path towards automation. In alignment with our bank strategy, our lines of business wanted to increase the frequency of feature releases. We came here to transform infrastructure, remove that stigma of us being the bottleneck, and really improve the delivery of our services. These drivers aligned us in the direction to look towards the cloud. Since we are a Microsoft shop, naturally, we chose Azure. When we adopted our cloud strategy, we needed to ensure what we are provisioning follows repeatable patterns. And because we are a financial institution, it was important that security and risk were at the top of our minds. We needed to make sure that we baked in as many security controls into our code. We started out with Terraform as a pilot. And after we found out this could meet our needs and our goals, we shifted to Terraform Enterprise and realized what we could accomplish there. We started out with provisioning our private data center in 2018. The first workload we automated with Terraform was provisioning of servers in our VM environment. We really wanted to get our feet wet on-prem, and since then, we've grown our automation journey. Our app dev teams have a demand to go serverless and leverage cloud-native paths. In order to ramp up the adoption, we had to make a culture shift. We built a team focused on cloud enablement and the transformation of infrastructure. Terraform was a key partner in helping us build that. Our cloud engineering started out with just one person and has grown to 6 today. With our small team, we were able to provide a central control plane where we publish our modules containing all the infrastructure and security guardrails. Our app dev teams can go into a workspace and simply modify the variables to right-size a service, which will get them peer-reviewed by our team. We put the work in developing our modules up front to avoid having to re-provision infrastructure resources over and over again. Today, PaaS is our preferred cloud model in Azure. We've codified over 40 services and have 60 applications running in our cloud environment. All these applications and services have all the infrastructure guardrails around network and the security guardrails, enforcing RBAC, CIS, and NIST controls. In fact, we are one of the top 200 consumers of Azure nationwide. Naturally, we selected HashiCorp as our automation partner. Our goals: to reduce the number of manual handoffs, ensure we maintain the infrastructure and security guardrails, enable developers to self-serve and consume. Now, just as Microsoft and other cloud service providers commoditize servers, which historically had to be created, customized, and configured on-prem, we've digitized our infrastructure offering, providing a service to our app dev team. We've abstracted the infrastructure and security complexities by packaging them within our Terraform modules. We've been able to improve the value stream of infrastructure delivery from months to weeks. While the provisioning infrastructure takes hours, the business processes and controls surrounding them take the most of the time. Our North Star is going to be the end-to-end automation, which we hope to achieve with the integration of our processes. The next iteration to adopt this is going to be HashiCorp Sentinel. We want to introduce policy as code to automate the key areas of governance and strengthen our preventative controls. We want to enable other teams to self-serve, pick and choose from a menu of services with a ServiceNow front end, and have the infrastructure delivered to them in a matter of hours. As we continue to mature, we look in alignment with our parent company's strategy to take advantage of the opportunity and leverage their scale to help foster and support our innovation. Back to you, Armon.
Awesome. Thank you so much, John, and great to see that kind of story and that journey. And I think what's great about that is in many ways echoes, I think, the journey most of our customers go on in terms of going through that process of how do we build that central team and really get to operating at scale. And I think the journey many of you have been on. So with that, I want to shift gears and talk about some of the new capabilities. And so let's sort of bring it to 2022. So sort of jumping right in, right? Terraform 1.3 is sort of the latest release and newest version of Terraform that just recently went generally available. And I think one of the core capabilities that we introduced as part of that was really thinking about how do we refactor a large and growing Terraform code base, right? So I want to take a look quickly at how this actually looks. Right? Let's start with sort of this basic example where we have all of our infrastructure in a root module, right? We have VPC, we have an Amazon instance, we have a bunch of our configuration here. And now we outgrow this and we want to modularize it. So what we've introduced is the notion of the move block, right? So what this allows us to do is refactor our code base and say, we're going to move those resources out of our root module and into a submodule. So now we're refactoring, defining that submodule. And now this allows us to redefine effectively what that infrastructure looked like. To instead of having all those raw resources, we basically instead said, great, we've factored that away. It's now inside of this nice handy module that we have. This makes it reusable. We can share that module and allows us to sort of dry up the code base, right? And that move block gives Terraform the right sort of hint that, hey, this resource doesn't need to be recreated. It already existed. We're just refactoring the code base and moving it into a submodule. So taking a step back, I think, oftentimes, I saw a great reflection on this on Twitter, which is refactoring isn't a sign of failure, it's a sign of success. Meaning your code base was successful enough, the project was successful enough, you've grown to the next phase of maturity, that great, it makes sense to refactor it, and now you have these reusable components. You've learned from that and kind of made it to a point where it makes sense. So how do we support that journey and really push some of those improvements into the core Terraform language? That's what we've been really focused on with some of those usability improvements and the move block. So I'm super excited about this, and certainly we've seen from more mature Terraform users the need to have some of these capabilities to refactor and manage a growing code base of Terraform. Next, the other piece, and we sort of talked about it briefly, was early over the summer we introduced the notion of drift detection. So when we think about Terraform, day one, obviously it's used to stand up a set of infrastructure. But then a core principle behind the notion of Terraform plan is the idea that infrastructure will drift, right? It doesn't necessarily stay in the state we first described it at. Things might fail, users might point and click, in a console and change configuration, right? Things just start to go astray. So how do we actually get notified of that and deal with it proactively rather than finding out, weeks, months later, the next time we maybe interact with that workspace? So this is where we really introduce the first class notion of drift detection. So what does that actually look like? Once we have sort of these workspaces under management, now we're actually just going to continuously scan for drift in the background. And that way we can actually get a proactive alert that says, hey, for example, this instance, some of its tags changed, right? Maybe it's no longer tagged production. Someone changed some of the rules on our security group as an example. We might want to get a proactive notification via an email, a Slack, a webhook, etc. Because some of this might be an issue, right? Like maybe there's a security, reason that we want to go into and look at why did that subnet rule change in a security group, right? So this has been part of our push into how do we really think about moving beyond just the day one stand-up into doing a better job day two and beyond, right? And so I think another piece of that has really been thinking about, okay, well, what does it mean for our infrastructure to be in a known good state? So with Terraform 1.2, we introduced this notion of preconditions and postconditions, right? Much like you do with software testing, sort of like an inline assertion with your code, right? We want to assert certain things are always true, otherwise we're not in a known good state. So what does that look like within Terraform? Great, in this case, let's say we're sourcing, an AMI image that we're supposed to deploy from HCP Packer, and then we're using that to provision an AWS instance. We might want a post condition, right? An assertion effectively that says the AMI instance that we're deploying is always the latest available instance, right? We don't want to deploy an older version that maybe has a security vulnerability or whatnot. So we want to assert that this is always true, right? And so the way Terraform handles preconditions and postconditions is as it's executing, if it gets to a precondition that fails, it will prevent the construction of that resource, right? So much like sort of an assertion, you don't want to continue if your precondition fails. Terraform detects that, warns you, and prevents the creation of whatever that resource is. The post condition gets verified afterward, right? So we'll create the resource and then assert, great, is this post condition true? Generally speaking, you would hope that your pre and post conditions are true day one when you first run Terraform, right? Or otherwise, it's probably something strange about the original kind of specification. The question is, how do you make sure that it stays true over time, right? Because great, yes, the moment we applied Terraform here, surely we deployed it with the correct image, but that might not stay true over time. And so that's what really brings us to this notion and what we're excited to introduce today, which is the idea of continuous validation. So what we want to do with continuous validation is make sure that those conditions that we're asserting about our infrastructure, those assertions stay true over time. So let's take a look at what that actually looks like, right? So we're going to start off here by going into a workspace and actually enabling these health checks, right? So this will enable both the drift detection that we just talked about, as well as the continuous monitoring. And so what this basically tells Terraform is that it's okay to be running these checks in the background, right? So periodically, we're going to be checking for these assertions, looking for any drift, and then we can see, great, we got some sort of a warning. Now, when we can come in, we can actually see, great, we see that some of these health checks are not passing, right? So we're looking at both drift and continuous validation at the same time, and we can drill into one of these instances and see, for some reason, we're no longer running the latest available image, right? And you can imagine there's many reasons this would have happened, right? When we first deployed this infrastructure, great, obviously it deployed with the latest version, but in the meantime, maybe there was a security patch, maybe there was a new version, maybe there was an operating system update, right? There's any number of reasons why the base AMI is no longer up to date, but oftentimes what we see is there's a disconnect. The teams that are managing that, that golden image, if you will, are not the same as the application teams, right? Goes back to that divide between platform and app team. So the app teams often don't have a way of knowing that they're running an older version or there's a security vulnerability or whatnot and that they need to update. So this gives them a more proactive sense of, hey, okay, I'm running a wrong version. I need to maybe rerun Terraform to deploy the newest thing. And so how could this kind of happen, right? I think this kind of brings us to maybe talking a little bit about the HCP Packer service. So for folks that are maybe unfamiliar with Packer, it's a tool very similar to Terraform for building, artifacts, production images, whether it's a AMI image, it could be a VMware image, could be a Docker container in an infrastructure as code way, right? So much like Terraform. So when we run Packer build, it's going to then go and consume the configuration, the infrastructure as code description, and then build an artifact. That could be a container, could be an AMI image. And it's going to publish those, but then the metadata can get pushed into the HCP Packer registry. So this will then keep track of effectively, great, what's the latest versions, what's a production image versus a dev test image, et cetera. And then we can query those out of Terraform or Ansible or any of our other tooling and use that to basically say, great, what's the latest version that I should be deploying, right? So what does that actually look like? So here we might log into HCP Packer. We can see we have a list of images. In this case, within that, we can see there's different iterations, different channels, right? So we have, multiple builds, V1, 2, 3. We have a production, testing, and development channel. And so we might come in and promote from our version 2 to our version 3 image and push that out to production, right? So now all of the applications that deployed the V2 image are in some sense out of date, right? All of our production environments that were baked on that V2 need to be updated. And so this is how that continuous validation helps us to close that loop, right? The team that's managing these golden images and saying, hey, great, Patch Tuesday comes along, we need to rebuild the underlying image, we can push that out, and now our downstream teams who are consumers of that image can get notified that they need to pick up the latest update, right? So the next kind of key piece as we think about the sort of standardization around Terraform is the Sentinel policies, right? So we introduced this in 2017 as our policy as code language, right? At the time, I think it was pretty early about talking about policy as code. Certainly we've seen it come a long way in the meantime. And I think one of the common things people have asked for is, much like with modules, how do we get a little bit of that reusability, that shareability that we have there? And so we introduced Sentinel policies available in the public registry as well to be able to solve that problem, right? So what does that look like? Very similar to providers, very similar to modules. Now through the registry, you can click into policies, do a search. In this case, we see these are a set of AWS foundational policies for, I think, CIS. Yep, so we can go in and say, great, here's the set of policies. I want to check those, and then I want to be able to import them into my environment and have that sort of reusability, right? So this makes it a lot easier to get started with Sentinel and build on top of the community modules as well as the ones that HashiCorp publishes. But I think one of the common things has been great. Sentinel made a lot of sense in 2017 when nobody was doing policy as code, and we sort of needed to kind of push that forward as a standard. In the meantime, there's multiple other community standards, right? So can we support other things beyond just Sentinel? And so I think one of the things we've been kind of asked about is, great, the policy as code workflow makes sense. We want to embrace that and use it. But can we have more flexibility and choice of language and framework? So to that end, super excited to introduce today the introduction of support for Open Policy Agent as well. So this gives you now the ability to define OPA policies alongside Sentinel policies and have them operate in the exact same workflow. So let's take a quick look at what that looks like. This is available today in Terraform Cloud and coming soon to Terraform Enterprise. So if we look at that one, very, very similar workflow to what we're used to seeing here with Sentinel, right? We can go in and say, I want to create a new policy. And then, great, we can select between Sentinel or OPA. We need to provide, the same sort of input. So give the policy name, maybe a description. We can select different enforcement modes. So meaning advisory, we just want to warn the user if they fail the policy, versus mandatory. You have to pass this policy to actually make a deployment possible. And then you can see this description, the actual policy code is Rego. It's no longer the Sentinel input. So it looks a little bit different, but functionally it's the same core workflow. And then here we're going to assign it to the Azure baseline. So great, any of our workspaces that are subject to that set of policies are going to pick this up automatically. And now when we go through and we can do a run, we can see that much like the existing workflow, it now happens inline, right? So these OPA policies are running inline post-plan in the same way Sentinel policies would run, right? And we can click into that and see, great, one of our advisory policies failed, but that's not going to prevent us from actually doing a run. It's just going to warn the user that, hey, maybe you should think about this, right? So very similar workflow, gives the users that additional flexibility. I think this has been a long time ask, so super excited to see the native OPA support landing. Now, kind of coming back to that idea that we have this divide between sort of the core infrastructure, core platform teams, and the app dev teams, one of the things we've seen, right, is the rise of use of the private module registry to be able to create a bit of that leverage for those teams, right? The platform teams, the infrastructure teams, they're going to create those set of reusable modules that they'll define the core infrastructure patterns, databases, web apps, networks, et cetera. And then the application teams don't need to be as much of an expert, right? They can come in and consume those modules, and they're somewhat abstracted from the underlying details of it. Now, the thing we've seen over time is that has lowered the bar because now our teams don't have to be as much of an expert, but there's still a bar. You still have to do infrastructure as code. You still have to know what Terraform is. You still have to maybe be connecting that to your CI/CD environment and having a workflow around it. And so I think the ask has been great. We have a set of customers that are happy with that, right? A set of users who are like, that makes sense, and I like infrastructure as code, and I like, having that sort of a more VCS-driven workflow. But there's a set of users for whom that's still a bit of a high bar, right? As they're getting started with cloud infrastructure, that's still sort of a tall ask. So I think there's been an ask of how do we make infrastructure more accessible, potentially for the development teams, but potentially for non-development teams that, find that they need infrastructure but don't want to learn some of this stuff. So that's what really brings us to what we're excited to announce today, which is a no-code provisioning workflow built around Terraform. So let's take a look at that as well, right? So very much starts with that private module. Once again, we come in and we say, great, we're going to define these by our platform teams. In this case, we might have a blueprint here for a web server running on AWS. And now we can push this provision button, right? And this is going to ask the user for a few key inputs. In this case, what production, do we want production or development channel? They'll provide a few key sort of inputs to this. But they don't have to write any HCL. You can see they're not creating a repo. They're not sort of having to install Terraform. And then it's creating a workspace for them, and executing that for them automatically. They didn't really have to know what's going on underneath the hood here. But at the end of the day, they're able to come in and provision and get the infrastructure that they need, right? So now they could click into outputs and get what they need and say, great, here's my end URL for my applications. I didn't really have to understand infrastructure as code, create a repo for it, define modules, set up a VCS interconnect, all of that kind of fun stuff. So really making it easier. So when we think about kind of those different audiences, right, in some sense, it's a question for us of like, what's the level of sort of infrastructure maturity or infrastructure sophistication? It tends to be that the core publisher teams, the core platform teams are the most sophisticated, right? They have to understand this stuff deeply because they own it, they manage it, right? And they're delivering it as a service, right? But then you have your consumers, some of whom are going to be comfortable with infrastructure as code. They're more mature. They're more sort of comfortable with that. And then you're going to have the folks that maybe want that UI-driven type of an approach, right? So as we think about these different audiences, we're trying to make it easier and sort of think about what does each one of these groups want. At the same time, we constantly want to give users more choice, more flexibility in what they're doing, right? So our core producers, they're probably writing these modules in HCL for Terraform. But then for our infrastructure as code customers, they might want to use a native programming language, right? They might like HCL, and great, that's a native option. Or they might say, you know what, I'd prefer to write my infrastructure in TypeScript or Java or Golang, right? And likewise, they might have a set of colleagues that say, you know what, I don't want to do that at all. I want to point and click through the interface. And that's okay. All of these are valid options, and we want to support all of that. So a big focus for us has been the CDK for Terraform. And we took that generally available earlier this year. And that allows us to define infrastructure in native programming languages in addition to HCL, right? And you can interoperate with the full Terraform ecosystem, reuse all of the modules written in HCL, reuse all of the 2,400 providers. And so what does that actually look like? Here's a basic example in TypeScript, right? And you can see that we're importing the CDK Terraform provider. And then we're implementing, in this case, an EC2 instance, as code within a TypeScript environment. And so underneath, this is translating it to sort of Terraform, right? It's going to generate and treat Terraform as sort of the intermediate representation. So that gives you full access to the whole Terraform ecosystem and interoperability with all of the different components of it, right? So we're super excited about this. Been getting great user feedback. And again, it goes back to our view that ultimately it's about choice, whether it's Sentinel versus Rego, whether it's about TypeScript versus Python or HCL. To us, what we really care about is that core user workflow and then giving as much choice as we can. So taking a quick step back on some of the Terraform announcements, just a quick recap, Terraform 1.3 went generally available. We've introduced continuous validation to really look at how do we make sure our infrastructure stays valid day 2 and beyond. No code provisioning to lower the bar and make infrastructure more accessible. Sentinel policies coming to the registry, as well as native OPA support, and Terraform CDK going generally available as well. So lots of great updates. There's even more sessions around Terraform and the whole ecosystem later today, so encourage you to check that out. So now shifting gears a little bit, I want to go and talk about the application layer, right? So this brings us much closer to those application teams, and this is where we have Vagrant, Nomad, and Waypoint, right? So starting and talking about Nomad, our goal with Nomad has always been to build an application orchestrator that's both incredibly simple, incredibly flexible, and incredibly scalable, right? And so this notion of flexibility was built into the very idea of how Nomad works. From the very get-go, it was able to schedule containers, but it didn't stop there, right? It allowed you to schedule VM-based applications, allowed you to schedule Java jars or static binaries, or as you'll hear later on at the conference, WebAssembly applications, right? Firecracker VMs. So the idea was that in the end, it doesn't matter what we're orchestrating. There's an application workload that needs to be bin packed across an infrastructure. That infrastructure might be 2 Raspberry Pis, or it might be 50,000 CPU cores across multiple data centers. But how do we make that really elegant and simple? So that flexibility has been built into the heart. And I'm super excited to see the new emerging class of workload, whether it's lightweight VMs with Firecracker or WebAssembly, being built on top of that, right? The next big one has been a focus on simplicity. How do we make orchestration very, very simple, right? And so over the last few releases, we've been constantly looking and saying, okay, where are the sharp edges? How do we make Nomad just a little bit easier, right? So one of the big improvements that landed as part of Nomad 1.3 was native service discovery, right? Previously, you effectively needed to use Consul as the service discovery engine alongside Nomad. So we'd deploy our applications. Nomad had a native integration with Consul, so it would do the service discovery and registration. Now, you can use the provider being specified here as Nomad, and Nomad will actually provide a native service discovery capability, right? So it will allow you to register and discover the services that are under its management. And of course, it can interoperate with Consul if you have things running outside of Nomad or need a richer service mesh capability, but it doesn't require it. So for getting started and simple use cases, it can be entirely self-contained for service discovery. What this then enabled is for us to do a much simplified traffic ingress solution. So if you're using a partner solution like Trafic, for example, it can directly integrate with the service discovery APIs of Nomad and allow that ingress to happen without an additional kind of components and machinery. In this case, you can see to enable Trafic, we're adding 2 tags to allow traffic to that service and provide a little bit of configuration on how the HTTP routing should work, right? And so this is really about focusing on how do we make this much, much simpler to operate this infrastructure, especially when you're just getting started. Of course, the other piece of this has been, what about our secrets, right? We have API keys, database user and passwords, certificates, etc. So not a surprise, Nomad integrated tightly with Vault to be able to do that secret management. But then that meant for simple use cases, you had to also have a Vault cluster, right? So that added another layer of complexity to getting started with Nomad. So super excited to announce today the general availability of Nomad 1.4. And a big, big push as part of Nomad 1.4 has been to make that even simpler, right? How do we remove that dependency for these simple use cases where maybe we're just using static secrets, right? We don't need the full capability of Vault. We're not doing dynamic certificates and dynamic secrets. We just need a static variable. So as part of that, we're introducing a secure variable store, right? So let's take a look at what that actually looks like. So in this case, we're going to switch to the command line and actually define the variable. Right? So here we're going to define a new variable for our Redis job, in this case, the password that the user needs to provide. So we'll specify the job and the particular task that it should bind to, right? So, and then great, we're providing the password for it, right? So this scopes the variable to a particular job, a particular group, a particular task, right? And so then we can come in and see through the UI. We can also manage those same configurations of variables. And so if we click all the way in, great, we can see the job that it's bound to. The password is there, great. It's all integrated and very sort of simple as part of both CLI and UI-driven workflow. And now we can actually modify the Nomad job description. So we can see Redis is reading its config from its config file. And we're going to take the static value, the static username and password that's hard-coded here, and replace that with a variable reference, right? So rather than hard-coding these secrets, now we're going to dynamically fetch it from Nomad's internal secret store. And so we don't have to check in a job file that has any secrets. We don't need a separate setup of Vault or any configuration between them. We can just use this native capability. And here we can see, great, we've deployed that Redis instance. It's running and healthy. And if we click into it, we can see the definition, this being sort of the expanded Nomad definition. And we see that there is no hard-coded secret in it, right? So this prevents that leakage that was possible, where now it's like, great, anything that you're going to see in the logs or through the APIs is just this variable reference. The secret's only materialized in runtime for that application, right, at the Nomad client edge, right? And obviously, variables are encrypted at rest, encrypted in transit, and protected by Nomad's access control system. So what that brings us to is, effectively what you needed to get started with Nomad before was the full suite, right? Like, yes, you needed Nomad, but service discovery was provided by Consul, secrets were provided by Vault. So to get the whole experience, you really need all 3 of these pieces. And now with Nomad 1.3 and 1.4, that's dramatically simplified, right? So if you're getting started, you can start with literally a single Nomad node, providing the orchestration of compute, providing secret management, providing all the service discovery, and you can scale that from a single Raspberry Pi to 20,000 nodes, right? So super excited about the work the team has done, continuing to make it the simplest orchestrator. Now, taking another look at the growing sort of app landscape, I think the challenge we've seen is there's sort of an explosion of tooling for our application teams to deal with, right? I used to joke that, when I started programming, it was as easy as I FTP'd into the environment, I dropped my new PHP file, we hit the reload, and boom, that was your deployment. And now it's sort of this like Pan's labyrinth of tools you have to go through just to do a deploy, right? You get a PhD in YAML. So, as we look at that and say, okay, well, great, these tools were incredibly powerful, but they've made our developers' lives very challenging, right? They have to learn a million different tools. And so how do we start making this simpler? Ultimately, developers really care about their core workflow, right? So it's like, great, I want to build my application. Well, okay, today it's like, am I building a Docker container? Because that's a totally different workflow than if I'm building my serverless app or I'm building a VM-based app. But fundamentally, I want to do a build. I don't really care, right? Same thing when we talk about a deploy. Am I deploying an ECS application, a Kubernetes app, a Lambda app, right? Something onto my vSphere installation. Each of these now has a different workflow that my developer has to learn, right? And then when we talk about actually doing release management of that, once again, a bunch of different tools, bunch of different workflows, right? So just an incredible amount of complexity. Again, these tools are all powerful. They all have allowed us to up-level our operations. Certainly, FTPing files into production had its own problems, right? So how do we sort of think about simplifying this? And that's ultimately why we created Waypoint, right? It was to really look at it and say, okay, what our development teams care about is their workflow. They want that to be simple. They want that to just be consistent. But our platform teams, yes, there's a reason we brought these tools in. They're allowing us to do things in a much safer, more scalable, more secure way than FTPing random things to prod, right? So when we look at Waypoint, right, the goal is how do we up-level that abstraction, right? So it's a very high-level HCL description here of what is a build, what's a deploy, what's a release. And you can see there's sort of a provider-esque nature, much like Terraform, where we're saying, great, the deploy and release in this case are going to use Kubernetes, right? But those could use other mechanisms. It might be different if we're on ECS versus Kubernetes versus VMware, right? So this has been a big focus for us. We released Waypoint 2 years ago, really looking at how do we make developers' lives easier, but give operators the flexibility they need. And so we introduced HCP Waypoint over the summer into private beta, and excited to really open that up today with HCP Waypoint moving to public beta officially. So as part of this, it's available today. You can sign up and get started. It's free to get going with it. And excited to get your feedback. And I want to kind of show a quick example, right, of some of what we're talking about and what are the use cases we're trying to make simpler here, right? So in this case, great, we have our definition of our Waypoint application. This example is now using ECS, so we can see, great, the build is going to use ECR as the container registry. We want to deploy it onto an ECS cluster. But then the variable of where that ECS cluster is actually running is coming dynamically from Terraform Cloud, right? And again, this goes back to that notion of this divide. My application team, they care about building and deploying and releasing that application, but their ECS cluster is probably managed by an infrastructure team, right? The infrastructure team is providing the underlying infrastructure and managing it for many different application teams. And so the team doesn't necessarily have to know how that cluster is deployed and managed. They're just saying, great, some other team's responsible for it. I need to know the information to deploy to it, but I'm not managing it, right? That actual infrastructure is probably being managed with Terraform by a platform team on our behalf. So we just need to import the key outputs that we need to use, right? So then ultimately, what does our developer need to know? Well, they just run Waypoint up. They don't actually have to care. That's going to then source the application from Git. It's going to run the Docker builds and build the container for them. It's going to push it into the ECR registry. They don't really have to know how any of this plumbing is working, right? And then it's deploying the application onto ECS and saying, great, here's your endpoint. You can go talk to that, right? The developer didn't have to know. We could change our registry from ECR to Artifactory. We could change it from ECS to Kubernetes, and the workflow would be exactly the same, right? And so then, great, we can click into the actual HCP Waypoint UI and see that that same deployment is here. We could have watched it along through the UI as well. And the user can click through and say, great, I want to see the application that I actually deployed. And we can see here's our successfully deployed application. So when we talk about what are the goals here, it's really threefold, right? For our developers, it's how do we have a simple and flexible workflow, right? That kind of shields them from the complexity of the underlying platform, right? So again, it was just one command for them. It was Waypoint up, and that orchestrated the build, deploy, release process. They didn't really have to know what those components are. We can swap them out, and it doesn't really matter, right? For our operations team, though, it does matter. We own that infrastructure. We operate that infrastructure. We have to be able to debug it. We have to be able to evolve it. We have to customize it. So for them, we want it to be extensible and customizable. So that's why when we look at this configuration, Each of these blocks is customizable. We could say we want to use ECS or Kubernetes or ECR or Artifactory, right? And we have the flexibility to source these configurations dynamically from various systems, right? Whether it's Vault or Artifactory or Terraform, et cetera, right? So the goal is much like Terraform has the providers that are extensible. Here we also have providers that are extensible with sane defaults, but then you can customize them as you need. Great, we have a default behavior for Kubernetes, but do you want to bring your own Helm charts and override our default behavior? It's extensible enough to support that, right? And so it's really this higher level concept that we're trying to get to, which is application delivery as code. Much like infrastructure as code is what Terraform enabled, right? It was a different workflow, a different paradigm of managing it. How do we bring that same concept up to the application level and make that consistent across these different layers, right? Build, deploy, release being sort of the key parts of that workflow. But I think they're not the only parts of that workflow, right? I think those are essential, right? You can't really escape them. But there's other parts that might be unique to your organization, right? So you might say, actually, in between build and deploy, we do a security scan, right? And we use, X-ray, or we use Sneak, or we use different tools to validate the infrastructure. So you might want to be able to customize that. So as part of that, we're extending Waypoint with what we're referring to and introducing as custom pipelines, right? So this is the ability to then extend that core build, deploy, release to support an arbitrary number of steps, an arbitrary sort of workflow to fit it into whatever you need to do, right? Going back to that extensibility. So let's look at a very simple example. In this case, we're going to define a multi-step pipeline that does a multi-step deploy, right? First deploys to test, then deploys into production, and builds on top of the existing sort of build, deploy, release capability, right? We can then execute sort of the arbitrary pipeline. In this case, we're going to just run our multi-deploy pipeline. And much like it ran before, but now it's going to do a two-step, right? It's first going to deploy it into our testing environment, right? So we can see it's going to do build, deploy, release here into test. And then we'll go right into the second part of this pipeline, which is doing it to the production environment, right? Obviously, this is a very simplistic example, but what we've seen in the early feedback from our users is, great, that's build, deploy, release makes sense for our most simplistic use cases, but particularly in larger enterprises, more complex, mature environments, there's a lot of other pieces. I might want custom CI actions. I want security scanning. I want different approval steps, right? So we want to be able to bring all of those things in and fit them into Waypoint. So you can almost think about it as the meta orchestrator, but it's doing it in a way that we can kind of mask that complexity for our dev teams. Again, the focus is let's hide the plumbing and make it easy, right? So taking a quick step back, lots of updates here with Nomad 1.4, really the introduction of secure variables and making it much easier to operate Nomad. It can be a single slim binary to run your global clusters. But 2 is then HCP Waypoint, moving that into public beta, making that much more accessible. And 3, custom pipelines as we think about how do we fit Waypoint into all of the different sort of workflows that we see users have. So that's all I have today as part of the opening keynote. And very excited for day 2 content. We've got a lot of great talks about new capabilities, whether it's Terraform, Waypoint, Nomad, lots of other great sessions for the rest of today. So hope you all enjoy. And now I want to hand it back over to our wonderful MCs to share a bit more about today's programming. Thank you so much and enjoy day 2.